Okay, so sorry I kind of did the most exciting part of this experiment in the lab video. Usually I try to leave it so you can see. I try to do maybe the boring things or don't do anything at all and leave the exciting things for you. But I did the copper and magnesium. Magnesium, it lit up, and then I left you to do the copper and aluminum and the copper and iron, and nothing happened. So be that as it may, our next job as scientists is to see if we can make meaning, admittedly from a pretty sparse set of data. But I'm hoping this one thing was not lost on you, even with just these three little experiments, and that the one thing I'm hoping was not lost on you was that the most reactive metal was the only one to light up the LED. Aluminum and iron, as we know from our experiments on reactivity series, are less reactive than magnesium. And so another way to say this is you could say when the reactivity difference is biggest or largest, that's when you have an LED light up. And you could think of it a quick application for this. If you're an engineer for a battery company, you would want to find metals that are the farthest apart in reactivity. And in fact, this is the case. So if you were to use something even less reactive than copper, like gold or silver or platinum over here, you would see the LED actually light up brighter. If you were to use something more reactive than magnesium, like calcium or strontium, you would see the LED light up brighter. It also works like this. If you were to use two very reactive metals, like calcium and strontium, even though they're both very reactive, you would not see anything lit up. So I'm just providing some additional data so that we can try to make meaning, and just to drive home the point that it's the difference, evidently, based on this experiment and what others have found, it's the difference in reactivity that leads to the generation of electrons and therefore electricity, and therefore the ability to light up things like an LED. One other thing I want to touch on is this battery. I should have mentioned this in the launch video, but I never did. I never said what the purpose of this battery was, and it's just to give a little bit of a power or voltage boost to the whole system. Because even magnesium and copper in our simple, very rudimentary battery, even though it's the best pair amongst these three, it simply wouldn't be that enough voltage to produce enough electricity to light up this LED. So if we just give it a little 1.5 volt boost, 1.5 volt boost, it's enough to pop it over. In the lab write-up, we actually wrote down to try two 1.5 volt batteries in series. So if you have another 1.5 volt battery, you can just put it right here, put them together. Something interesting might happen with these two, because now you have 3 volts assisting this weaker set of metals. And so if you have the time in this battery, give that a shot. It could be pretty interesting. But even with this, the important thing to say is it doesn't change our conclusions. This was not a variable; it was a constant in all 3 experiments. So it doesn't, it doesn't change our conclusions. So that's a landing video for Lab 5A.